Good morning. Good morning to all. Now the number is very poor. I am waiting. I have already informed physics madam to close the class. She has already closed. I expect all should participate today. I expect more number. All should present. The number is very poor. After one class, as these two classes are consecutive classes, you should ready accordingly. Just after one class, other class will start immediately. So you should ready. Some are coming and again leaving the class place. Now the number is very poor. Very few are in the line. Just you are clicking here, then you are leaving the place. Now you tell with the completed 3.4. I have given extra. I had given problems from 7 to 17. 7 to 17. I have given yesterday. I think most of you have completed questions. Today I will discuss the miscellaneous exercise. Miscellaneous exercise. After miscellaneous exercise, I will proceed to determinants. The next chapter, after miscellaneous exercise. From miscellaneous exercise, I will give hints and you will do some problems. Then I will proceed to determinants. So all should come now. Only 10 students are online. Only 10 students are present this moment. Whatever number present directly attached to me are shown on my screen here. On this laptop screen, it is visible. Once again, good morning. Good morning all. Okay. Now open your book, page 100. In page 100, that is miscellaneous exercise on chapter 3. From that exercise, question number 1, 2 and 3, these three problems are based on principle of mathematical induction. Principle of mathematical induction, these three exercises, three questions. Question number 1, question number 2, question number 3, based on principle of mathematical induction, though it is not written PMI, but the problems are from that. N belongs to capital N, it is written. It means for natural numbers. So question number 1, 2, 3, in all the cases, you have to follow PMI, principle of mathematical induction. First, now you do one simple problem. Out of question number 1, 2, 3, 3 is important. Miscellaneous exercise, question number 3. You see now, miscellaneous exercise, question number 3. Here, a to the power n is given. That is your Pn. The given statement Pn. You have to prove P1 is correct. Now you start, write Pn first. Pn means a to the power n. That value you write 1 plus 2n minus 4n, n 1 minus 2n. It is your a to the power n. In the place of n, if you write 1 in a numerator, sorry, a to the power 1, you will get a right hand side. If you put n equal to 1, after simplification, your result is coming 3 minus 4, first row. Second row is coming 1 minus 1, which is given here. Then we write P1 is true. Write down P1 is true. Let Pk is true. Let Pk is true means a to the power k, a to the power k equal to, write down Pk is true. Pk true means a to the power k equal to, just to put k in place of n. Put k in place of n. You will get 1 plus 2k minus 4. Then second row, k 1 minus 2k. Replacing n by k, you will get pk is true, then write to prove pk plus 1 is true whenever pk is true, then write down the statement pk plus 1. Write down pk plus 1. Left hand side, write down a to the power k plus 1. A to the power k plus 1 equal to, write down right hand side first row. Write down first row 1 plus 2 into k plus 1. Second element of first row minus 4 into k plus 1. Second row first element k plus 1. Second element 1 minus 2 into k plus 1. I mean in the given condition, replace n by k plus 1 both the sides, you will get the statement pk plus 1. Then start from left hand side. Your left hand side is a to the power k plus 1. A to the power k plus 1 can be written as a to the power k into a, or you may write a into a to the power k. The value of a to the power k obtained from pk. Now you write value of a to the power k obtained from pk. Previous step. Then usual multiplication of two matrices. Use your matrix multiplication, simplify, you will get the right hand side. Then you write the conclusion. Now the given statement true for all natural number n, or n belongs to capital N. In this way, you will work out question number 1, 2, 3. After class, you will work out today 1, 2, 3 by applying principle of mathematical induction. Question number 4 and 5. Question number 4 and 5 based on properties. If A and B are symmetric matrices, prove that AB minus BA is a skew symmetric matrix. This question is in its previous exercise in multiple choice. Multiple choice. Your starting is like this. Question number 4. Question number 4. You should write AB minus BA dash, means AB minus BA in bracket, then full. Then you put dash, means start from skew symmetric matrix. Then AB whole dash minus BA dash. In the place of AB dash means B dash into A dash minus BA dash means A dash B dash. Then in the place of A dash you write A. In the place of B dash write B. You take minus common from the total. You will get again minus AB minus BA. That means it is a skew symmetric matrix. In the same way, you try question number 5. From question number 6, 7, 8, 9, all are easy problems. In question number 6, A given, question number 6, A given, you have to calculate A transpose. A dash means A transpose. Changing rows into columns, columns into rows. Then multiply, maintain the proper order. First A complement, first A transpose, then A. A transpose into A, multiply it, equate the result to the identity matrix of order 3. Then equate the corresponding elements. Then you can get the values of x, y, z in question number 6. A given, calculate A transpose by changing the rows into columns, columns into rows. Then multiply A transpose into A. Order is important. In matrix multiplication, order is important. So first A transpose, then into A. Equate the result to I. I means 1, 0, 0, 0, 1, 0, 0, 0, 1. Then equate the corresponding elements. Equating the corresponding elements, you will get your required result. Now in question number 7, multiply first 2, Then multiply the result to the third one. It is an equation. In the right hand side O is written. Right hand side O is written. O stand for zero matrix of the same order. O stand for zero matrix of the same order. Then equating the corresponding element to 0, you can calculate value or values of x. Now you solve question number 7 and question number 9. You work out now. Now calculate 7 and 9. Quick. In between, I will collect your attendance. How many are present? I will see here. From your names, I will collect the attendance. Every day we are maintaining the attendance and we are sending the information to RO office. So all should present. Yesterday 17 present. Today now the number is same 17. Now the number is 17. Yesterday it was also 17. Today is also 17. I expect more students should participate. Here from the name, sometimes I am confusing. Samruddhi present today. Shelly present now. Swadhin, Abhishek Mohanty, Prayas, Ananya, Devi Prasad, Avilas, Susmita Jana means Tirtha. Susmita Jana means Tirtha. Tirtha. Then Pradeep, Muhammad Aid, Avinash, then Smriti Rekha, Swadhin, Sai Jyoti. Those are available now. Your names are visible here. Those are attached to me. The number is fluctuating 16, 15, 17 like this. Means when you are leaving the screen or leaving that place, your name is deleted from the screen here. So you also and write through live chat. Yes, Avinash, Shelly. Yes, good morning to all. Those are on the line. Abhishek, you written, you can start. Avinash, you tell me, am I audible to you or not? Avinash and Abhishek, both of you write whether I am audible or not audible. Yes, Om Prakash, Kostov, good morning. You have started writing very good morning, I think. Avinash says, okay. Now try to complete question number 7 and 9. I think 7 and 9 is very simple to calculate. First to multiply, first to matrices. Multiply the result with the third one without changing the order. As matrix multiplication is not commutative, but it is associative. You can multiply first two, that result you multiply with the third, equate to zeros. Each element to 0. You will get the value of x in both the cases, question number 7 and 9. And in question number 10, it is a practical problem. You have to write in matrix form only. In both the bits, how can you write in matrix form? You can calculate the result, question number 10. But how can you write in matrix form? That is important. Write down in matrix form, multiply them and get the result. There are two bits in question number 10. In question number 11, find the matrix X so that X into this matrix is coming that. Now I want to analyze question number 11. You all see question number 11. Okay, 7 completed. Proceed to 11. You stop writing there and see 11. 11 needs discussion. Question number 11. You have to find matrix X. How can you determine the order of the matrix X? X is multiplied with the given matrix. Matrix multiplication possible if number of columns of first equal to number of rows of second. As the number of rows of second is 2 rows, X must have two columns. So X is a matrix of 2 columns. Then proceed to the result. In a right hand side, products contain a matrix whose order is 2 by 3, 2 rows and 3 columns. That is the order of number of rows of a first and number of columns of second. So number of rows of X will be 2 and the number of columns of X is also 2. So X is a matrix of order 2 by 2. From this, you have to calculate first its order. Then that is very very important. What is the order of X? Now you obtained X is a matrix of order 2 by 2, 2 rows and 2 columns. Then you may take first row AB, second row CD, then use your matrix multiplication, equate the corresponding terms to the right hand side and find the value of A, B, C, D, you will get it. So you take X equal to first row A, B, second row C, D, X is a matrix of order 2 by 2, multiply these two matrices, equate the corresponding element of right hand side, then you will get the values of A, B, C, D, then you write X. Now you do quickly question number 11. Work out now. Question number 11. Work out question number 11 now. In the place of capital X, write down the matrix. First row A, B, second row C, D. As the order of X is 2 by 2, 2 rows, 2 columns. Multiply. Then equate the corresponding element of right hand side, left hand side and right hand side. Left hand side in terms of A, B, C, D. Right hand side given. Equating the corresponding elements, you will get A, B, C, D. Then you write X. Okay, Swadhin, you have written, I think correct. You have completed 11. Subhranshu, now you are coming. Okay, Subhranshu, you have done. Now the total number became 17. So today you work out this miscellaneous exercise, all the problems. In question number 12, you have to apply again PMI, principle of mathematical induction, for question number 12 also. Question number 12, principle of mathematical induction, here it is written, then prove by induction. By induction means principle of mathematical induction. Using principle of mathematical induction, you can prove question number 12. Okay, the remaining problems you try to solve the remaining problems and do in your homework copy and put today's date. For miscellaneous exercise, you put today's date. After completing question number 11, you proceed to the next chapter, determinants. Come do 11, then proceed to next chapter, that is determinants. I will proceed to determinant chapter. Whatever doubt will be there, after reopening, I will clarify all your doubts. Whatever may be the number of doubts, but you try to collect your reference books. You can see your reference books and solve. Yes, Barsa, listen. Barsa, you have written how the order of X is 2 by 2 or column is 2. X is a matrix and another matrix is written. Matrix multiplication is possible or defined if a number of columns of a first matrix is equal to number of rows of a second matrix. In the left hand side, X into the matrix given, it has 2 rows. As the second matrix has 2 rows, then X must have 2 columns, so that matrix multiplication is defined. As matrix multiplication is defined, X must have 2 columns. As matrix multiplication defined and we are getting right hand side is given a 2 by 3 matrices. Matrix multiplication is defined, so X must have 2 columns. As Second matrix has 2 rows. Matrix multiplication is defined if number of columns of a first matrix is equal to number of rows of second. Okay, Barsha, do you follow it or not? Now proceed to determinants. Proceed to determinants. What is determinant? When a square matrix is written with 2 bar, we are calling it as determinants. Determinant is a value assigned to a square matrix. Determinant is a value assigned to a square matrix. You just consider a square matrix. Write down A, B, first row, C, D, second row. Just to write it. Write a square matrix. First row A, B. Second row C, D. It is a square matrix. Replace the square bracket by 2 bar. Simple bar. The symbol like modulus. That indicates determinant. Determinant means you have to calculate the value. How can you calculate value? Just to multiply A with D minus C with D. I mean AD minus BC. AD means A11, A22 minus A21, A12. When you are taking first row AB, second row CD, the value of the determinant is the result A into D minus B into C. Now you calculate one simple result. Here you write first row 2, 5, second row minus 1, 3. It is a square matrix of order 2. Again you write, just to check, first row 2, 5, second row minus 1, 3. If you write that a 2, 5 with 2 bar, then it is a determinant. This determinant value is obtained like this: multiply 2 into 3, then minus 5 into minus 1. 5 into minus 1. Now the result is 6 plus 5, your answer is 11. So determinant is a number, determinant is a value, but matrix is an arrangement. Matrix is an arrangement in a rectangular form, but all matrices don't have determinant values. Only square matrices have determinant values. Square matrices, square matrix of order 1, square matrix of order 2, square matrix of order 3. In that way, a square matrix have determinant value. By replacing square bracket, if we put 2 bars, you will get determinant. Then we will calculate the value of the determinants. Now you see your book, open that page number 104. Page number 104. First, you read the remark. Remark 1. For matrix A, that A with a 2 bar is read as a determinant of A, not modulus. It is written clearly. You will read it as determinant of A. Throughout the chapter, its meaning is determinant, not modulus. Only square matrices have determinants. Okay, this is the value. You all proceed to page number 104. Suppose a question is doubt, not completed, you stop there, proceed to page 104. Whenever if required, I will come back, but not now. Proceed to page 104. You see now, determinant of a matrix of order element itself is the value of the determinant. Suppose a matrix contains exactly one element, then that element itself is the value of the determinant. Suppose a square matrix of order 2 is given, means 2 rows, 2 columns given. It is given, you see, A equal to A11, A12, first row. Second row is A21, A22. Then value of the determinant is, by replacing square bracket by 2 bars, you will get the corresponding determinant A11, A12, A21. The value of the determinant, you see how it is calculated, A11, A22 minus A21, A12. This is the formula to calculate D1 and example 2. You calculate the two values. Calculate example 1 and example 2. Calculate example 1 and example 2. Done both. Very good, Saijwati. You have completed both the problems. Very good. Page 104, example 1 and example 2, both are determinant of order 2. Apply your formula A11 into A22 minus A21 into A12. This way you can calculate value of the determinant. Very good. Many of you have done now. Samriddhi completed. Then Kaustav completed. Prayas also completed. Then Surupa, Devi Prasad, Indira, Om Prakash, Barsa, you all have completed both the problems. Okay. Now I will proceed how to find determinant value of a square matrix of order 3. How to calculate determinant value of a square matrix of order 3. First of all, you write a third order matrix 3 by 3. I mean a square matrix of order 3 with the symbols. First row A11, A12, A13. Second row A21, A22, A31, A32, A33. You all write this with bars. I mean write down determinant of order 3. Then I will tell how can you expand, how can you solve a third order determinant. First of all, you write in the symbolic form. You see the page number 105. Page 105. Determinant value of A is given. Determinant A is given, that is with symbols. First row A11, A12, A13. Page 105. Determinant value of A. Second row A21, A22, A23. Third row, the elements of third row are A31, A32, A33. Now, how can you calculate? How can you calculate the value of the determinant? Value of the determinant of a third order determinant can be obtained by expanding along a row or along a column. Expanding along a row or along a column. Here, I will tell you now how can you expand along a row first. Suppose I am selecting row 1. Suppose I am selecting row 1. How can you get the value? You have to write first minus 1 to the power 1 plus 1 into delete first row elements and first column elements. Remaining you write in determinant form. Actually minus 1 to the power 1 plus 1 with that element A11. minus 1 to the power 1 plus 1. Then we write A11, leaving first row and first column. Take the remaining elements, write in determinant form. So determinant is coming A22, A23, A32, A33. This is your first term of the determinant. Then put plus minus 1 to the power 1 plus 2, first row, second column. And then the corresponding element is A12. Then leave elements of first row and leave elements of second column. Elements of first row and elements of second column will be deleted and take the remaining. Your remaining elements put in the determinant form. You see, it is written as minus 1 to the power 1 plus 2 A12, determinant of A21, A23, A31, A33. Then you see the third term. The third term is coming minus 1 to the power 1 plus 3. 1 stands for row number, 3 stands for column number. First row, third column. The corresponding element is A13. A13. Then leave row 1 and column 3. Collect the remaining elements, put in determinant form. The determinant so obtained is A21, A22, A31, A32. In this way, you are getting three terms. Sum of these three terms give you the value of the determinant. Sum of these three terms when you are expanding along row 1 means along first row. You have to calculate these three terms, then add it, you will get the result. Now we will do one problem. How can I apply this? If we will do one or two problems, then it will be clear to you. You see now, example 3. Example 3, page number 107. Example 3, page number 107. You all proceed to page 107. Page 107. In page 107, example 3, determinant is given. It is a third order determinant. 3 rows, 3 columns, always square matrices. Here we will take the determinant. That triangle shape symbol is given. That is your symbol for value of the determinant. We are using that delta. That is like triangle. That symbol is used for the value of the determinant. When it is expanded along third column, it is expanded along third column. Why along third column? Because the third column contains more number of zeros. When zeros are there, obviously the terms become 0 and your calculation will be easier. When more number of zeros are occurring, then you will get less calculation. So expanding along C3, we are getting the result. So first element of C3 means column 3 is 4. Minus 1 to the power 1 plus 2. Sorry, 1 plus 3. 1 plus 3 means it is 4. So minus 1 to the power 4 is 1. Then the element is 4. Leave first row and third column. Leaving first row and third column. Remaining minus 1, 3, 4, 1 is your determinant. For other two, write 0. Next term is minus 1 to the power 2 plus 3. 2 plus 3 means 5, so it is coming minus. Then the corresponding element is 0. Leave second row, third column. You will get 1, 2, 4, 1. Then plus 0. Why the term is plus? Because the third row, third column means minus 1 to the power 3 plus 3, which is 6. Minus 1 to the 6 is positive. So plus 0 into leaving the elements of third row and third column, remaining is 1, 2, minus 1, 3. Now you will get 4 into minus 1 into 1, it is a minus 1. Then minus 3 into 4 or 4 into 3, it is 12. Then minus 0, then plus 0. Why? Not equal to calculate. After multiplying 0 with the determinant, the value became 0. So not equal to calculate the other two determinants of order 2. Other two terms are 0. So your answer is coming minus 52. Now question for you. Do same example 3. Expand along row 1. Expand along row 1. Row 1 means 1, 2, 4. Check whether you are getting minus 52 or not. You must get minus 52 if you are correct. You may expand along any row or any column, value of the determinant remains same. Now question for you, example 3, work out this determinant expanding along row 1. Expand along row 1 and tell me whether you are getting minus 52 or not. Work out quickly. Subhranshu, you have done. Smriti Rekha also completed. Prayas also completed. Surupa completed. Okay, you all should do quickly. Example 3. Same question I have given here. Already you know the answer should be minus 52. But expand along row 1. Along first row. Expand the determinant. Whether getting? Yes. Example 3. Expand the determinant along row 1. Okay. Now proceed to example 5. Page 108. Next page. Page 108. Do now example 5. In example 5, two determinants are given equal. Two determinants equal means their values are equal. Determinants are equal means calculate value of the left hand side, calculate value of the right hand side, equate that two results, then you get value of x. When you are solving left hand side, it is coming 3 minus x square. When you are solving right hand side, answer is coming 3 minus 8. 3 minus 8. Hence x square is equal to 8. If x square equal to 8, then x equal to plus minus 2 root 2. X equal to plus minus 2 root 2. Now you work out some problems from exercise 4.1. Here I am giving some questions. You work out. Exercise 4.1. Exercise 4.1. Question number. Question number 1, 10. Question number 2, second bit. Question number 2, second bit. Back. Okay, back. No. Just back. Okay. Okay. It's okay. It's all right. Question number 2. Second bit. Okay, why this type of letters are coming? number of number of I think number of that. So now question number one, question number two. Let us have different. Okay. Work out second bit. Question number one and two. One, two, second bit. Question number five, first bit. Question number five, first bit and second bit. Work out these problems now. Then I'll discuss some properties. I'll take maximum 5-6 minutes more. Only very few minutes are left. Okay. Proceed. Very few minutes are left. So you work out. Yes. One completed, two also completed. Saijoti, very good. Kaustav completed. Saijoti completed. Samriti also. Okay. Proceed to question number five. Question number five, first bit and second bit. First bit and second bit of five. Exercise 4.1, question number 1, 2, 2 only second bit, and 5 first bit and second bit. Work out 5. It is up to you. Along any row or along any column, you can expand. Third order determinants are given. Both. You may expand along any row or any column. Choose the row or column containing more number of zeros. Yes, Indira also completed. Very good. Pruthvi completed. Om Prakash also completed. Surupa, Samriddhi also you have written completed 1, 2. Proceed to question number 5. Kaustav completed 5. Very good. Saijut also 5, I think. Proceed. 1, 2 second bit, 5 first bit and second bit. Then I will tell one more property. Then I will close the class. Sharp 12 noon, I will close the class. So you do quickly. Yes. Pruthvi completed 5 first bit. Very good. I expect you all should complete. Now the number present is 11. Very, very poor. If you will not attend the class, you cannot complete the problems in time. This is the time to do the problems assigned by me. After class, you should do. Actually, I have already requested to my colleagues not to disturb you after 2 p.m. Only 4 classes per day. All teachers are requested not to take classes after his or her scheduled time. Your first slot or first period is always 8 to 9, then 9 to 10 gap, it is for Ramayana, then 10 to 11 second slot or second period, 11 to 12 noon third, and 12 to 1 no one will take class, that is time for Mahabharat or Ramayana, that one. Then from 1 to 2 p.m. again another class, 1 to 2 p.m. A teacher to whom it is assigned, he or she can interact, take the class or assignment only that 1 hour given. After 2, don't disturb your parents. You are taking the mobiles, you are sitting for mobile and laptop. No. Strictly use these 4 hours. And other time, you should devote your time with your book and copies, work out the problems or assignments given by your teachers. Other time don't use mobile or computer. So strictly you follow this one. If other teachers are disturbing you, just to communicate me, inform me. I will communicate to principal sir. Actually, we have decided to give you sufficient time for self-study. Self-study is very important for your practice. Today, I have taken the class of 50 minutes, and that 50 minutes means 3 times, 4 times of 50 minutes is required to complete the exercises. Okay, very good. 5-second bit also completed by most of you. See now one more property. One more property, you stop writing, listen first. You proceed back. One property, you see, I want to discuss. Suppose one matrix is given. Suppose a matrix is given. That matrix is given third order matrix. When you are multiplying a constant k, you are multiplying that constant k with each element. But when a determinant is multiplied by a constant k, then your answer is k to the power 3 whole into a. I mean, if the order of the matrix is n, determinant value of a k a, if a is a square matrix of order n, A is a square matrix of order n, k is a non-zero constant, then determinant value of ka is equal to k to the power n into determinant value of a. Your property is like this. Again, we'll discuss this property. By using this property, you can solve question number 3, 4. These two problems you can solve. Here, question number 3. So that determinant value of a 2a equal to 4 into determinant value of a. Here you should calculate left hand side, calculate the right hand side, then check. Question number 4 also same. A given. Question number 4, a given. How can you get 3a? Multiply 3 with each element. You will get 3a, then find its determinant value. For right hand side, calculate determinant value of a. Multiply 27, then you will see the two results are same. So today you do all the problems of exercise 4.1. So homework for today, miscellaneous exercise of chapter 3, miscellaneous exercise of chapter 3 and exercise 4.1 of chapter 4 means determinants. So next period we will discuss the properties of determinants. As it is based on properties, you must prepare yourself properties of determinants. Then I will discuss all the properties again one by one, but you prepare yourself first all the 7 properties given in your book. So write down and check again the homework given today. Miscellaneous exercise chapter 3, exercise 4.1, all the problems and properties of determinants. You see yourself all the properties. I will discuss the properties one and each and every properties I will discuss one by one. Property 1, property 2 individually I will discuss in the next class. Thank you all. I want to take your attendance now. Attendance, you write thank you and close your mobile or phone. First you write thank you and send to me quickly within 1 minute so that I will take the attendance. For attendance, you write thank you now. Oh, now I'm reading the names. Those have written Saijoti, Pruthi, Prayas, Varsha, Swarupa, Om Prakash, Smruti Rekha, Samruddhi, Devi Prasad, Kaustav, Shelly, which name? Ryan Evans written here. You write your name. Then Indira, Those are present, write a thank you so that I will take the attendance. How many present now? The number is very less. Okay. Indira also you have written. Yes, Subhransu. Subhransu. Then next period you must okay Saswat with you. Saswat's name Arian Evans. Okay. Thank you, Samradhi. Thank you. Thank you all. Have a nice day. Any problem you can intimate through WhatsApp message. If any problem you can send me through WhatsApp message through this group. Okay. Thank you all. Thank you all once again.